Assalamu alaikum. My name is Saeed Usama and my roll number is 21T09. In this video, I am going to explain the Lab 2 of Digital Signal Processing Lab. Objective. The objective of this lab is to signals representations. In task 1, entering the starting point and the limits. In which we in task 1 in which we have n 0, -1, n1, -3 and n2, 3. In which we starting the point n2 and the limits n1 and n2 for the index n. The second generates the index n from n1 to n2 and then we create the step signal x by checking if n is greater than or equal to 0, in which we generate a binary sequence where the value is n, and then we plot the step signals against the index n using the stem plots, and then we create a step signal starting from a specific point and 0 and plots it, and here we have a output of the signal. In task 2, we skip the stimulates summation n -0, in which we have the index 0 is 1, the same as above task 1, and 1 -5 and 2 5, in which we also generates the index n from n1 to n2 and creates the step signals x, and then we plot the graph. Here is the output of this task 2. In task 3, script to stimulate the exponential signals xn is equal to s alpha n. Here is the same as above the task 1 and task 2, in which we set the starting point n0 and the limits n1 and n2 for the index n, and then we generate the index and then generate the index n, and then we stem functions x is equal to 3 exponent 5 and exponent n, and then we plot the step signals against the index n using the stem plot, and here we plot the signals. You can see the graph. In task 2, write a function to stimulate unit impulse sequence. The output of this task 4, in which first we have a function unit impulse sequence length and positions. Unit impulse functions has two arguments, starts and limits. N is equal to start limit that generates the index n from start to limits. Impulse is equal to 0, impulse with 0 with the same size as the index n, and impulse n is equal to 0 that set the value of impulse to 1. In simple terms, these functions create a unit impulse sequence where the value is 1 at index 0 and 0 with the specific range, and here then we create two labels, x labels and y, that's the x is equal to simple index and y is the amplitude, and then we give the titles unit impulse sequence, and then we plot the signals, and here you can see the output of this task 4. In task 5, we create a function to stimulate unit step sequence. Is same as the above, in which we create function unit step sequence length and positions. Step sequence is equal to 0, step sequence position n is equal to 1. N is equal to start limit that create the index n ranging from start to limits, and step is equal to 0, 0 matching the size of the index n. In simple, the function generates a unit step sequence where the value is 1 for indices greater than or equal to 0 and 0 within the specific range, and then we plot the signal. Here you can see the output of the unit step sequence. In task 6, we use the function of task 4 and 5 both. As above of the task 4 and 5, we use unit impulse and unit impulse and unit step sequence, the same as above, and start limit that generate the index n from start to limits, and impulse 0 at the index In this, in the both functions, we creates a unit impulse sequence where the value of n at index 0 within the specific range. And the second function in task 5, we also generate the unit step sequence where the value is also 1. The both we combine the task 4 and 5, and then we plot the signals. Here you can see the output of this task. In task 4, write a program that can help to flip the given signal. In this function, we flip signals that define a MATLAB function named flip signals, and that takes one argument signals. It returns the flip signals. Flip signals is equal to flip LR signal that used to flip the signals. The input signals from left to right create the flip signal. In simple terms, this program takes a signal as input and returns the same signal flipped horizontally. And here you can see the output of this flip signal. In task 8, write a program that can able to perform index scaling the given signal. The input of the task 8, in which we define a MATLAB function named scale signals that takes two arguments signal, the input signal and the scale factor by which the index will be scaled. And then we also use the commands of subplot for, and then we use the command for plotting the signals and also give the labels x and y. This this function is also used to take a signals and a scaling factor as input and return the simple signal with its index scaled by the specific factors. Here you can see the signals in the output as a output. Now write a program that can be able to shift the given signal input. In this MATLAB function named shifted signals that takes two arguments, signal the input signal and the shifted amount that we use the amount by which the signal can be shifted. And we also use to shift the signals. And here you can see we use the commands of subplots plots for plotting the signals and x label y labels. The purpose of this lab is to take a signals and shift by the specific amount and wrapping around the signals if necessary. And here you can see the output of this signal. Now moving towards the task 10, write a program to simulator zero order hold. In this task, first we define the functions named zero order that takes three arguments, input time vector and input signal vector, output time vector. And here you can see we use the three command. Then we plot when we use the plot command that plot the signals, and we use hold on command. In this program, we simulate a zero order hold, which approximate a continuous signals by holding the value of the signal. The signals constant between the consecutive time points. Here you can see the output of this task 10. Now moving toward the task 11. Write a program to stimulate first order hold, in which we also use the function MATLAB command first order hold, and that takes three arguments, input time vector, input signal vector and output time vector, that returns the output time vector, and then we hold output signal vector. In this we also found in the input time vector that calculates the slope of the line segment between the current and the next time point. In the simple term, the code stimulates the first order hold, which approximate a continuous signals by linearly interpolating between consecutive time points. Output of this task 11. Okay, that's all from my side. Allah Hafiz.